So in the past, we've talked about graphing quadratics in vertex form and standard form. Now let's take a look at how to do that when we have a quadratic function in intercept form. So intercept form is y equals a times the quantity x minus p times the quantity x minus q. So let's look at an example. Let's do y equals negative, let's see, x plus 3 times, let's do x minus 3, x minus 3, x minus 3 times x plus 1. Okay, so first step, like always, is let's find the vertex. So the vertex for this type of quadratic is going to be, just write this down, it's going to be p plus q over 2. So remember, when we find these two things here, we need to ask ourselves what makes this term in parentheses equal 0 and this term equal 0. So our p term in this case, a positive 3, would make this equal 0. So it is a positive 3. Like I said before, you could just memorize that it's the opposite sign of what number is here, but it's good to get the application behind it. We could talk about that in a later video. So 3 plus, and then what makes this term equal 0? A negative 1. So 3 plus a negative 1 divided by 2. So this is just 3 minus 1 over 2, giving us 2 over 2, leaving 1. So let's go ahead and plug this back in to our original function and get the corresponding y-coordinate for the vertex. So let's see, f of 1 equals negative 1 minus 3 times the quantity 1 plus 1. Alright, let's see. That gives us a negative 2, positive 2. Let's see, negative 4, distribute the negative 1, a positive 4. So our vertex is 1, comma 4. Let's go ahead and graph that right now. And remember, the x-coordinate of our vertex is also our axis of symmetry. So let's also label that. Alright. And before we actually plug in some other points and get the actual sketch of the graph, we know that this parabola is going to be downward opening. And we know that because our a term in this case is negative. So when we just have a negative sign here, it's an implied negative 1. So our point right here is the vertex, and it's also a maximum. Alright, now let's actually get the real idea of what this graph looks like. Let's plug in, let's do 3. Well, let's do 2 actually. Alright, so f of 2 equals negative 2 minus 3 times 2 plus 1. Now let's see what that gives us. We have our negative sign out in front. 2 minus 3, negative 1 times a 3. Let's see, negative 3, distribute the negative 1, positive 3. This point is 2, comma 3. Let's go ahead and plot that, get that same color. And we have our symmetrical equivalent on the other side of the axis of symmetry. Now let's do 3. So f of 3 equals negative sign out in front, 3 minus 3, and 2 plus 1. Well, we have a 3 minus 3 here, and that's going to equal 0. So by default, we know this entire expression is just going to be 0. So this point is 3, comma 0. Let's go ahead and graph that. There we go. And its equivalent on the other side is right over here. Alright, so let's sketch this. Something like this. And don't forget your arrows indicating that this graph goes to negative infinity. So there we have it. This is how to graph a quadratic function in intercept form.